This is MAP4C, day 23. The lesson today is lesson 3.2 on relationships and scatterplots. The goal of the 3-minute review is to distinguish between 1 and 2 variable data, which is what we did yesterday. Very quick 3-minute review, not a 3-minute review. In each case, does the situation represent 1 or 2 variable statistics? Well, truck weight is a variable. How much does this truck weigh? And mileage is a variable. How much mileage, in miles per gallon or whatever, does a truck get? Well, this is 2 definite different variables. This is 2 variable data. This one is a histogram, right? Histogram because the x-axis is a number line, just like the y-axis. And notice the y-axis, though, is just a count of how many trees were in between these ranges. This is a histogram. This is 1 variable. See, that's it. Not variable. Not even 3 minutes. On to the lesson. The expectations are to interpret graphs to describe a relationship. And again, what we're going to be doing is doing some scatter plots. And you remember this from grade 9 and from other grades. The idea of the first thing in the table is the x variable, and it's the independent variable, and it goes along the bottom, right? This is the second thing in the table is the y variable. It's the dependent variable. Dependent, and it goes along the side. Notice I've actually plotted these. I labeled each of the trucks with a different letter so we could see them. And you don't have to watch me plot those. You can do that on your own probably. A few things I want to mention about this scatter plot, though. Notice that because all these values were way away from 0, I put a little break in the graph and started at 3600 and then started my scale after that. Similarly, for mileage, I put a break in the graph, even though I didn't have to. I probably could have went up by 1s and still done a decent job of that, of plotting the scatter plot. And then we can see the relationship between weight and mileage. Okay, so I'll let you have a look at that before we go on to the next example. I suppose you could pause. Example 2 is to go back and use the graph. Does the graph suggest a relationship between weight and mileage? If so, describe the relationship. Overall, it kind of looks like it's a downhill relationship, that if I read the higher weights, it'll give me the lower mileages, right? So we always read the x variable, the one on the bottom, as increasing. So I'm going to say as weight, truck weight, increases, overall the trend is, even though it's not exact, right? Overall, it looks like it's a downhill trend. Mileage decreases overall. And notice that this is a situation in real life that makes sense. Like, if you get a heavier truck, it's not going to get very good gas mileage, right? So this kind of makes sense. Which 2 trucks have approximately the same weight? So on here, I'm looking, well, which 2 trucks have approximately the same weight? And all the numbers look different. But if I look on the graph, which ones have about the same weight? Well, looks like B and D, right? They both have a weight of around 4,500. And that's kind of a nice thing about a scatter plot, is you can sort of see the general trend without getting hung up in the numbers. A weight of around 4,500. And I'm guessing that's in pounds, although the units weren't stated. What might account for the difference in mileage if 2 trucks have the same weight? So the idea is these 2 trucks here, B and D, both have a weight of around 4,500 pounds, but the mileage, how far they can go on a fixed amount of gas is different. So what might count for that? Well, I don't know much about cars or engines or anything like that. But I'm guessing, you know, this truck is probably just somehow more efficient than this truck. Even though they're the same weight, this one burns a lot more lot more gas. It gets a lot less further on the same amount of gas. So what might account for it? Saying maybe engine efficiency. And you can have efficiency. You can have a discussion with your classmates and add some additional information. Maybe let me in on it if you know more about trucks than me. But that might make sense. So this graph, you might use something like this graph to decide on what truck you want. You want an efficient truck rather than an inefficient truck. Okay, is that it for that one? Yep. On we go. Some definitions now. A blank is a relationship between two variables. We talked about this a little bit already. The magic word is a correlation. A correlation is a relationship between two variables. So if there's two variables that are related, we can say they are correlated. So a positive correlation means as the x variable increases, and we always read the x variable increase, and we always read from left to right, what happens to the y variable? Well, if the y variable increases, so as x increases, the output increases, means the line of best fit goes like that. Maybe the points are scattered all over the line like this. As x increases, y increases. X increases, y increases, it looks like that. That's a positive correlation. And it makes sense because this line has a positive slope, doesn't it? The opposite is a negative correlation. Now, notice that we always think of x increasing. That's because we always read from left to right on a number line, right? So whatever this happens to be, truck weight or years, we always think of the x-axis increasing. As the independent variable increases, the y variable decreases. So as this one goes up, this one goes down. It's going to look like that, isn't it? And the points might be, you know, spread out all over the place, a scatter plot like that. As x increases, y decreases. That's called a negative correlation. And that makes sense because the slope of the line of best fit is negative, this negative slope. So, and we're talking about these relationships in general today. Example 3, which would each have a positive correlation, negative correlation, or no relationship. So if the two variables that we're interested in are hours studied and test mark, so if we think of this as hours and test mark, what would we think? Well, if we only studied a little bit, we would guess that our test mark wouldn't be very high, right? That if we studied a lot, the hours studied was a lot, that our test mark would be higher. So we would think that, you know, as hours studied increases, the test mark increases. This should be a positive relationship. At least we hope so. Hours of TV watched and hours of exercise. So if we had TV and exercise, people that watch only a little bit of TV, well, maybe they would exercise a lot. And if you have had a lot of TV, then you'd have less time to exercise. So probably we'd think of this as going downhill. As the hours of TV watched, we always read the x-axis first, the hours of TV watched increases, the hours of exercise decreases, probably a negative relationship. The person's height and the sum of their phone number digits. So this is their height, and this is their phone number. Phone number. Well, whatever their height is, that doesn't have anything to do with their phone number. So probably there's no relationship, right? Probably be points kind of all over the place where this is the sum of their phone number, and tall people and short people, it doesn't really matter what their phone number is. There's no relationship. Income and years of education. This is an interesting one. Maybe we'll put income down here and education down here. we would think that if you had not very much education, you'd have not very much income, right? So maybe low income, low education would go together, and high income would be high education, right? Because you've got, lots of money, you can go to school, or because you went to school for a long time, you got a good job and have lots of money. Probably it goes like that. Positive relationship. As one goes up, the other one goes up, right? As one goes up, the other one goes up. And what's interesting is these could be switched. We don't know which one is the independent here, because it's first, we put this one down here. So we thought, maybe rich people can go to school longer. But maybe it's the other way. Maybe people that have more education, like this, you don't have to write this one down. This is education. This is income, dollar signs. People that go to school for longer make more money. We don't know. Maybe these are switched. This is a hard thing to tell. I'll talk about that later. This is even harder, this one. Years worked at a company and days absent. So we're not sure which one goes where, but we'll just talk about the variables as they're given. So this is years worked, and this is days absent. And this one is very debatable. I hope that you talk about this one with your classmates in class, because, what do you think? And people that only work for a company for a couple of years, how many days absent? Well, you could say, they're worried about keeping their job, so they're going to show up to work every day, where somebody who's worked for a company for 20 years, well, they can take lots of days off, right? Whether it's holidays or sick days or whatever. And you might think, it's a positive relationship. But another point of view, that's not a very good set of axes. Let me just fix that up here. Somebody else might think years and days absent. The people who only have worked for a couple of years, maybe they have lots of days off, and then they get fired. They never end up with if you work for the company for 20 years, you're going to show up to work every day because you like your job and you're staying with the company, and maybe it's a negative relationship. Well, that seems pretty logical too. Another person might say, well, you know what? It's probably just got more to do with the person. And there's going to be, no matter how many years you've been working, the days you're absent, there's people who take days off, and there's people who show up to work every day. It doesn't really matter how many years you've been with the company. This is debatable. What do you think? I'm not going to give the right answer, because there is no right answer. You would have to just back up your answer. And I hope you discuss this one with your classmates, because it is interesting. Last little point here, I think. Often in studying two variable relationships, it's unclear which is the dependent and which is the independent variable. And remember, dependent is the y-axis variable and independent is the x-axis variable. It says one way to think is to think if one variable is causing a change in the other variable. And sometimes it's not clear. So for instance, in our last example, if we had the TV and the exercise, right? We're thinking, if people are watching more TV, is that causing them to exercise less? Well, maybe, because if they're spending all that time watching TV, maybe that's the reason why they're not exercising very much, right? Or we could think of it the other way. Maybe when people exercise a lot, when people exercise a lot, they don't, I blew that one actually, didn't I? That one there is wrong. We said it should go the other way. We should have a little bit of TV, a lot of exercise, a lot of TV, not very much exercise. This is actually a negative relationship. Or it could be switched around, right? If people exercise only a little bit, they got lots of time for TV. Or if they exercise a lot, they might be too tired to watch TV, and it's a downhill thing. Like this. Does one cause the other? That's hard to prove. It's really hard to prove. And in fact, often some of these relationships don't have anything to do with each other, like TV doesn't make you not exercise, or exercise doesn't make you watch more TV or less TV. Maybe it's got something to do with the person, right? Maybe it's the amount of energy they have. If they've got lots of energy, they'll exercise more. If they don't have lots of energy, well, then they'll watch TV more, and it's got nothing to do. The exercise and TV don't have anything to do with each other. It's got something more to do with the person. And this is the idea of causing. One doesn't cause another. We're just looking for if they're related or not. And this one makes sense that they're related. So here's something. We've got one of the variables, the independent variable is coffee is consumed. So the x-axis, the independent variable, the x-axis is coffee consumed. And we want to have a positive correlation, so we want this to go up. Well, what might this be so that it's a positive correlation? There's lots of things you could think, like, for instance, if it was Tim Hortons, more coffee you drink, the more money it's going to cost you. So this is amount of money paid for the coffee. As I drink more coffee, the amount of money I pay goes up. So this is a positive correlation. That kind of makes sense. A little bit of coffee, a little bit of money. A lot of coffee, a lot of money. Negative correlation. So again, we want the x-axis to be the amount of coffee. And the y-axis is something that's going to make it so the graph is going downhill. Now, what might that be? As I have more coffee, well, what would go down? Well, coffee's supposed to keep you awake, isn't it? So maybe it's the amount of sleep you get. A little bit of coffee, a lot of sleep, but a lot of coffee, only a little bit of sleep. This kind of makes sense. As the amount of coffee you drink increases, the amount of sleep you get decreases. Negative correlation. And no relationship, well, this could be anything, right? We could just make up lots of goofy stuff, but maybe it's something like, and we want to have no relationship, so we think of points being sort of all over the place, and the line of best fit would just be right down the middle with no relationship at all. What might this be? Well, maybe marks, right? Does the amount of coffee you have determine what your marks are? Probably not. One might argue that, if you drink more coffee, you can stay awake studying, but I know lots of people who drink lots of coffee and they're not up studying. So probably this would be a no relationship thing, although you could probably think of one that's even less clear than this one. Who knows? The amount of coffee that somebody drinks and how much their car cost, or how many TV shows they follow per week. And there might be no relationship there, and that's the idea for today's stuff. Okay, that's it. Good luck with your relationships and scatterplot homework, folks. I think that's it. That is it.